Welcome to the Pole Shift News. Guys, it's the 12th of May. Woke up this morning, outside the window, a ground frost. I'm not saying it's uncommon for this time of the year, but the real sensors of climate change for us in the UK are the trees that was imported and not indigenous to this country. And you can see already that, there is the trees that have naturally been here for a lot longer than these ones that was imported have already put the leaves on. And then we've got these ones that are not indigenous to this country that were imported to this country during warmer climates, and they've managed to adapt to the climate very well, but they're the ones at the moment without the leaves on. So if you're looking for real climate sensors, then look all around you guys, because these things show us where their habitat is more generally enjoyed by that particular species of tree or plant as such. Now, in this video, I wanted to talk about our current project and why we've taken it upon ourselves to put these magnetometers around the world and what we expect to see as a result of studying these high intensity regions. But before I do, I want to thank those people yesterday that was giving some nice warm comments in the comment section of support for what recently happened on our channel. As you know, we're about 10% down on our funding for this month as a result of a few people taking things the wrong way. So big thanks to you guys. You are a few out of many, and I just hope we can encourage a few others to come on board and get us back up to where we was on the Patreon, and support us with maybe a one-off PayPal donation. It's entirely up to you. So let's get on with it. So we're looking at a temperature map on the left and a magnetic intensity map on the right that was produced by Swarm's data mission. Now you can see M1, M2, M3, M4, M5, M6 on there, M7 and M8. These four, M3, M4, M7 and 8 are yet to go out to their locations. We have M1, M2 in place, Southern California M1, Kentucky is M2, we've got Perth, M5 and M6, the Gold Coast. The 3 out of the 4 so far have already completed their test run for the first week, and now they're collecting the data for the first month. I'll explain why we've positioned them in a minute. Where we have M5 will be coming online over the next week with its first test results. Then it will go into a 4 months run to collect the data like the other 3 are at the moment right now. Now the reason why we put these magnetometers where we have is to track this lurching high intensity over the southern region. So we've placed them right on the fringe of where the main intensity is moving up towards them. So hopefully, within a few months we should start to see an increase in the readings in Australia. And we've also in America done the same. We've put it right on the fringe where not in the highest intensity region is, but in that mid-range area, and that is so that when we see the Canadian pole reducing in field strength, we'll be able to detect that. And with these magnetometers, we'll also be able to detect how fast the progression is of these intensities in these regions. I'm also interested, now I've got to go to the south coast of the UK Monday. I'm going to link up with Andy, who's an expert with these computer breakout boards, and see if we can resolve the problem so we can finish off the other 4 magnetometers, because it doesn't look like we're going to be able to get those magnetometer chips to suit the program. So we're going to change the program now to suit the chips, the new ones that we're getting, or we've already got. And we can get those other 4 out in those other locations, M3, M4, M7 and M8. M7 and M8 will be tracking that region of the planet where the magnetic intensity is at its lowest. It's also close to the region known as the South Atlantic anomaly. It's just referring to this region here, which you can see in the dark blue on the right hand map, of the lowest intensity over the Earth. When these regions, according to some supercomputer modelling systems, that have been produced to recreate magnetic reversals, and they have had some success, albeit on computer modelling systems. When these low intensity regions increase in size, it's an indication of, you know, a magnetic reversal speeding up. This is what they found when they run the program. Okay, I will just say that, you know, it is a computer program. We don't quite know how the magneto is generated in the core of this Earth. Some say it's to do with swirling molten iron in the centre, but somebody did point out, and I've done experiments on that, I really don't know if that is how the Earth generates its magnetic field. I have got some theories on that, but I mean, which would probably suggest more of a surface field charge all over the Earth. But that's a, you know, a theory in itself. But, you know, sticking to the standard model, they believe that the core is generating a magnetic field by swirling material inside in the core. And you know, what we're looking at is these regions. There's another reason why it's important to put these magnetometers on these regions, and another thing that we're going to be looking at is, as these high intensity regions progress, say in Australia, towards the magnetometers, what we're also interested in seeing is if the Arctic climate moves along with it. And that's why we've got the temperature chart on the left, because if you look at, especially over the northern hemisphere, you can see that where those lowest temperatures are also on the right hand side on the magnetic map, where the highest intensity magnetic regions are as well. So my prediction is this: we have seen the Arctic climate moving over Russia and down towards China. You know, we've had reports that, you know, some of these southern islands in China have received snow for the first time in many years. We've seen crop losses as a result of this surprise low temperatures, you know, on the farmers there, where they've lost, you know, millions of heads of cattle and thousands of hectares of grain as a result of these low temperatures. So, you know, a theory of mine is, you know, it's never been a case of coincidence. You know, we've got magnetic fields and we've got the lowest intensity, the lowest temperatures within these regions. You know, I think that there's a reason the magnetic poles form in the coldest temperatures, and that's because, you know, a few experiments which I've conducted where we've heated up, you know, magnetic bearing material to the point where it's lost its ability to hold that magnetic material. Now, I think, you know, temperature within the core, if it is being generated in the core, has a lot to do with where the poles are. If you look at the temperature map, you'll see all around the equatorial region, it's warm compared to the north and southern poles of this planet. And, you know, it shouldn't come to any surprise, but if you also look at the magnetic intensity map, you'll see that this is where the weakest magnetic fields are. So, you know, we're not only interested in, you know, finding out how fast the poles are migrating at the moment, we're also interested in, you know, how it is affecting the climate, and whether the magnetic poles are governing the Arctic temperature, and if they are, whether it is the migration of the poles at the moment that is tearing, you know, these temperatures along the progression path of the magnetic intensity, you know, regions. So that's why we've put our magnetometers where we are. We've put them right on, you know, the hot zones of where either, you know, in the Canadian incidents, you know, it is leaving that region. So we've got them right on the you know, fringe of where it's leaving that, you know, that high intensity region. So over there we should see in Southern California and Kentucky the numbers reducing, and the the nanoteslas, you know, reducing in strength over them regions. And in the case of Australia, where we've got those two magnetometers, we should see it increasing as that high intensity region moves towards the magnetometers, and we'll be able to see at what time rate, you know, it has increased, and that will give us an idea to forecast how fast or how long we've got before, you know, we do actually see a magnetic pole reversal. Over here in the UK, we've got the TriMag system, and that monitors the heading of the magnetic North Pole, and we track, as it migrates towards Siberia, its position. Over here in the UK, we also have a magnetosphere sensor, which is measuring, the intensity in the UK as the poles migrate. It gives us an idea of how fast our magnetosphere is depleting in field strength, at least over the northern hemisphere. And that is in a nutshell, guys. It is an important topic. It is a rare anomaly that's taking place in our lives, and I know that there have been failed magnetic reversals a lot less time than the full reversal and completed last reversal, which was 780,000 years ago. But the point is this, guys: we are overdue a completed reversal, and we are already 500,000 years overdue that reversal, because I say, like in many of the videos I do, on average it was between 350,000 years that we used to have a completed reversal, and this time it is gone an extra 500,000 years before it has entered this new period where we're in right now. And it seems to be that it is the case that we are going to see this time a completed reversal. And if it's not a completed reversal, then the only other thing that we should worry about is, because of the extra 500,000 years, has something slowed down in our core? And if so, could that put us on a track where we could possibly end up losing the magnetosphere of this planet? And this isn't fairy tales, guys. This is something that has happened to our neighbouring planet in our solar system. Mars had an atmosphere, it had water on its surface, and it had a magnetosphere. It had magnetic poles, and it lost the magnetic poles. We know that from studying, sending satellites over Mars with magnetometers on board. We know it did have a magnetosphere at one point, and we also now are learning the facts that when a planet does lose its magnetic poles, which protect it from the solar winds stripping away its atmosphere, what could be the result of that? And Mars is the perfect example. Now, it's not a matter of when these changes are going to start affecting us, because they already have, guys. And I want to just touch on one thing. Farmers usually have to invest a great deal of money into their equipment, and as a result of that, they take out loans. And if they have crop failures, they struggle to repay those loans off, and it puts the farm in jeopardy of being lost or snatched back by the bank on the back of borrowing. We're going to start seeing a lot of these farms, as a result of the climate not favouring the growing seasons properly, losing their land, and that is going to have a serious knock-on effect all the way up to us in the shops. We are already, even here in the UK, in a modern Western world, noticing the rising of the prices of food, and we're going to start losing some of these foods that we've got in the shops. We did last year, for a period of time, struggle to maintain some of the salad packs that we get here in the UK, and you wouldn't think we would have a problem, but we did. You're going to start seeing prices rise on food as a whole globally. When you hear there's been a 10% reduction in the crop output in the United States across all the ranges, that's a great deal, and that will affect the whole global food prices. When you start seeing China become less of an exporter and more of an importer, the food prices are going to start increasing. But it's not just that. We are going to start seeing arable land, which is good cropping land, go offline like we already have, but on a greater scale. We are in a time now where we really start to need to take out those insurances for our families and our loved ones and start preparing for this. If you're waiting for one of your local governments or somebody to come to your aid in a time of crisis, then you're going to find yourself very disappointed. It doesn't cost a lot to take some form of preparation. It could be in the form of a bug out bag and a small amount of food set aside, to see perhaps for a couple of months at least, you'll be in a better position if you have these things than if you don't. The signs, guys, are all out there, and I know it can be hard because, you go from one channel to the next, you see the same titles and this, that and the other, but, it is really a call for you guys to, take some form of action now. Don't be complacent, because you're hearing it a lot. You really need to get your stuff put aside and, take on board, that the Earth is going through some serious and dramatic changes right now, and the anomalies are being affected across the range. Weather is just one, and climate is just one. It's all the other anomalies which are probably associated but not yet completely accepted, to do with what is taking place recently in the last 100 years, and that is the magnetic pole reversal. So I'm going to leave it here, guys. There's a link down there if you want to support what we're doing. We're a real small observatory. We've got funds less than £1,000 a month to run all what we're doing now. There is an investment of time and money, personally by myself and a few others. I'm just saying it'd be great if we can encourage a few more people to come on board and support what we're doing, because at the end of the day, we might just be able to give you perhaps a couple of months upfront warning, that we have detected with our magnetometers that are all around the world now, of a rapid advancement in the magnetic poles, and that gives you at least probably a couple of months notice, which is going to be a massive beneficial to, I believe, all of us on the channel and at the observatory and on the website. So links are down there if you want to support us, and I'll catch up with you in the week, guys. Okay, as always, bye for now.